Hello and welcome to the latest installment of Office Hours by BitGartner. My name is John Kowalski. I'm part of the marketing team here, and just welcome. We'll be having a short presentation, maybe 20 minutes-ish long, followed by a discussion. We're here to answer your questions, alleviate some of the challenges you may be facing in your own facilities, and to generally help however we can. This webinar is being recorded. Following it, probably later today or in the morning, you'll receive an email from us with the recording as well as the presentation materials and anything else that comes up in the discussion that would be pertinent to sending on to you. So with that, let me introduce our speaker today, Mr. Corey Cohen, our Technical Applications Specialist. He'll be leading the webinar. So welcome. Oh, sorry, Corey, to interrupt. One last thing. If you have any questions, please enter them in the Q&A box located in the bottom right-hand corner of your screen, and we'll get to them directly, concluding Corey's presentation. So with that, Corey, it's all yours, sir. Thank you.
Thank you for that introduction, John. Good afternoon, everybody. Thank you for attending. So today's topic is liquid color measurement. So when measuring liquids, it can be a bit trickier than measuring the color of solid materials. And so today we're going to discuss some of the methods we have available for evaluating the color of various types of liquids. So liquid color measurement, you could say it falls essentially into two categories: solid colors, which are essentially liquids that are more or less opaque that you can't see through, and transparent liquids. So for solid colored liquids, this might include things like paints, inks, particularly cosmetics. It's desirable to evaluate cosmetics in a liquid state, things like lipsticks and nail polishes. And even food products. I've gotten some requests for over the years to evaluate the color of liquid food products. So solid colored liquids, this requires a non-contact measurement with a reflectance spectrophotometer, such as this one over to the right here, our Spectra 2 guide instrument. And this also requires that you draw down the material first in order to measure the color. And the other category is transparent colored liquids, which can include things like pharmaceutical chemicals, solvents, oils, transparent resins, and again, some food products. There are a number of specialized scales specifically for certain industries and for certain types of materials. And there are both visual and instrumental methods available for measuring the color of transparent liquids. So we'll start by talking about measurement of solid colored liquids. These are, again, opaque liquids that you cannot see through. And so the first step in evaluating one of these liquids is to do a drawdown. And so in order to do that, you'll need a chart. For those of you who aren't familiar with the term charts or our BICO chart line, these are a substrate. It's essentially cardstock that comes in a few different materials and different designs with black and white on them in order to act as a substrate for evaluating the color of the gloss or whatever you want to evaluate on your material in a repeatable and precise way. And our BICO charts in particular are very tightly controlled for things like color and gloss. And how different materials react to them so that you know that you're getting a repeatable and comparable evaluation every time you use it. So now that you have your substrate, your chart, you will need an applicator, some sort of applicator bar as pictured here. They come in a variety of sizes and configurations with different gap clearances. We also have wire wound rods, which are applicators which are more suitable for very thin liquids, typically inks. It's recommended to use wire wound rods to draw down inks. So you need those two, so you can, the chart so you have a consistent substrate, the applicators so you can do a drawdown of a consistent thickness. And as a bonus, if you really want repeatable, consistent drawdowns, you can use an automatic film applicator because different operators doing drawdowns will draw down a material with different speeds or apply different pressure on the applicators, and that can cause slight differences from drawdown to drawdown. So if you really want the most repeatable, the most comparable drawdown for the most comparable evaluation of your liquid, you really want to use an automatic film applicator where the speed is regulated and the pressure is regulated, and you're getting the same consistent drawdown every time. So after drawing down your liquid, the next step is to measure it with whatever color measurement device you may be using. We have a few here. We have our Spectra 2 Guide instrument, our latest spectrophotometer for solid colors, and then we have our BIC-MAC eye instrument, which is for materials with effect pigments in them. Mostly, in this case, it would be for cosmetics like nail polishes and things. And you can see here we have wet drawdown templates that are fitted for these different instruments. So the wet drawdown template, after you do your drawdown of your material, and while it's still wet, you can place the drawdown template on top of it. And we have different templates, again, that are fitted for specifically for different instruments. And then you set your instrument on top and take a measurement without having the wet liquid contact in the aperture. And that's very important because these instruments have an open aperture. The the insides, the light sources, and the detectors and all that are exposed. And so you really don't want to get liquid up inside the aperture because that's going to throw off your measurements in the future. So in order to have accurate and repeatable measurements, you want to avoid getting that liquid up inside the aperture. And to do that, you need to use one of these wet drawdown templates, which will hold the instrument up just slightly above the that wet drawdown so it doesn't get contaminated. You can see of these wet drawdown templates, the one on the bottom left is for our original Spectra Guide device. We also do have one for our newer Spectra 2 line of spectrophotometers. And on the right there, you can see the template for the BIC-MAC eye instrument. In the middle there, we also actually have one for our gloss meters as well. So whatever type of measurement you want to do, we can provide a wet drawdown template that will allow you to measure it without contaminating your instrument. So that brings us to our transparent liquids. And for this, we have a few different evaluation methods. So one of the most common evaluations or measurements done for color on transparent liquids, it's called the Gardner color scale, which was developed in the 1920s to evaluate the color of oils, varnishes, and resins. It's a scale going from 1 to 18. It ranges from water white, which means clear, to yellow to deep red, as you can see in the image there, the top left. And so there are visual and instrumental methods available depending on your needs, depending on how much you want to spend and how precise you need your measurements to be. We'll begin our Gardner color talk by talking about the liquid color standards. So this consists of a rack holding 18 tubes of liquid, progressing in Gardner color values from 1 to 18. And so the evaluation method here, first you would fill an empty tube with your test liquid, the liquid that you're evaluating, and then you would insert that liquid into a slot in the rack between two color standards. If you look at this image here, you can see on the top of the rack, there are these little circular holes that are designed for a tube full of liquid to fit through, and they exist between the existing liquid color standards so that you can visually compare your liquid to the color standards that are already in the rack. So you insert your liquid, you compare your color visually to the liquid color standards on either side, and determine whether the test liquid falls between those two standards or not. If they don't, and the test liquid is darker or more yellow or red than both standards on either side, then you would move the test liquid to a slot further to the right and evaluate again. If the test liquid is lighter or less chromatic than the standards on either side of it, then you would move the test liquid to the left and evaluate again. So the goal is to find two liquid standards that your test liquid falls between. And once you find that, you can evaluate your liquid in comparison to those two standards. So for example, let's say I have a test tube full of liquid, and I find that visually it looks like that liquid falls between, say, the 7 and the 8 color standard. If I evaluate the color and say that it falls exactly halfway between the 7 and the 8, I might say it's a 7.5. If it's a bit closer to the 7, I might say it's a 7+. If it's a bit closer to the 8, I might say it's an 8-. So you evaluate the color and come up with a color number designation in comparison to those defined standards. So the next evaluation method we have is also a visual evaluation method. This is called the Delta Color Comparator, and this consists of two wheels of glass color filters corresponding again to the Gardner colors 1 through 18. So whereas the rack of liquid standards is just a bunch of liquids that correspond to the Gardner color numbers 1 through 18, here we're using glass filters to reproduce those colors. And so you can see the apparatus here. There's a wheel on the left and a wheel on the right, and the wheel on the left has all of the odd numbered Gardner colors. So it has a glass filter corresponding to Gardner color 1, 3, 5, 7, all the way up to 17. And then on the right are the even colored Gardner numbers, 2, 4, 6, all the way up to 18. And so here again, you are going to fill an empty tube with your test liquid, the liquid that you're evaluating. You insert it into the slot in the comparator, and then you rotate the filter wheels until the color of the test liquid falls between whatever filter is selected on the left and whatever filter is selected on the right. So again, very similar to the liquid color standards, but whereas with the liquid color standards, you're moving the test tube itself to find the appropriate comparison. Here, you're actually rotating the filters, and the test tube stays in place. But once you find those two colored filters that most closely match the test liquid, or that the test liquid falls in between, you then evaluate your test liquid in the same way as a 7.5, 7+, 8-, whatever it may be. So that brings us to our instrumental color evaluation for transparent liquids. And we have two instruments for that. One is called the LCM4, and the other is called the LCS4. And they do look identical. They have the identical outer design at least, but the LCS actually has a lot more capability than the LCM. So the LCM has a simple set of scales, and the LCS is a bit more robust. So for the LCM4, the available scales are Hazen or APHA, which are essentially the same scale. It goes from 0 to 1,000. It's essentially a yellowness scale. It can evaluate Gardner color numbers. And one of the benefits of using an instrumental device like this rather than the visual method is you can get better precision, better resolution with this. So whereas before the closest or the best resolution you could get for your Gardner color was, again, your 7+ or 8- or whatever. This can measure Gardner color to a tenth of a unit. So it can measure it as a 7.2 or 7.3 or 7.4. So it's a bit more precise, a bit more accurate, and a bit more repeatable. It also has an iodine scale, a Savolt scale, and a mineral oil scale. So several linear scales, just a single number, meant for certain specific types of materials and certain specific industries. And that brings us to the LCS for, which again is a bit more robust than the LCM. It has a lot more capabilities. It can do CIE LAB, so your regular LAB color numbers. It can measure that. It can measure an LCH as well as Hunter LAB. And it can do color difference measurements, so you can measure a color in as a standard and store it in the instrument, and then measure your samples and compare it to that standard and get your EE value, DL, DA, DB, all that stuff. It comes in a variety of illuminants and allows you to utilize either the 2 or 10 degree observer for color measurements, whereas the LCM, I believe, is fixed on the C illuminant and the 2 degree observer. And it can do spectral readings, meaning it can do percent absorbance and percent transmission. This is the percent of light that is either absorbed or passes through the material at a given wavelength, and you can measure that at a 1 nanometer resolution all the way from 320 nanometers to 1100 nanometers. So that covers the entire range from UV all the way up through the infrared range. And so if you want to know what the specific absorbance or the specific transmission is of the material at, say, 543 nanometers, you can measure that, or you can measure just the entire spectrum and get a curve describing the percent transmission or the percent absorbance all the way in that entire 320 to 1100 nanometer range. We also have a variety of cuvettes available. We have what we call precision cuvettes, which are meant to be cleaned out and reused. But if you're working with a material that may be very difficult to clean out of a cuvette, or it may even be a little caustic and may damage the cuvette a bit, and you don't want to keep reusing those cuvettes, we do have disposable cuvettes as well. And we have different path lengths as well. So we have 10 nanometer square cuvettes. We have 10 millimeter square cuvettes, 11 millimeter round cuvettes, and 50 millimeter rectangular cuvettes. And the reason you might want to use a different size, the size is what we call the path length. It's the distance that the light has to travel through the material in order to get to the other side. And so for very light colored materials that may measure at the very, very low end of the APHA or the Gardner color scale, for a little bit better precision and in order to measure more clear differences between very light liquids that may have very subtle differences between them, you would want to use a longer path length, so that light has to travel through more of the material and you get a slightly more precise measurement that way. And so for that, you may want to use the 50 millimeter cuvette. And so in addition to all those things, the LCS can also measure all the same scales that the LCM can measure. It can measure the Gardner color, the Hazen, and it can measure additional scales as well that the LCM can't. So you see a list here on the right. This is actually not a complete list. There are additional scales it can measure. There are even scales for measuring whiskey, believe it or not. If you don't believe it, I'd be happy to do some tests for you. Just send a couple bottles to my attention at Bic Gardner. And when I receive them, I will go ahead and test them for you. And when I'm done with that, I will take some measurements with the LCS. So that concludes our brief presentation for today. And now I'll hand things back to John for our Q&A.
Thanks, Corey. I appreciate the willingness to help with some whiskey testing. So thank you. First question from Mark here. Does the LCS4 work with fluorescent whitening agents? Let me read that again.
Fluorescent whitening agents.
Yes.
That's actually not something I've ever worked with in this instrument before. So the photometric calibration, or the photometric measurements that it does, the percent absorbance and transmission ranges from that huge wavelength range, 320 to 1100 nanometers. But when you measure color scales, the evaluation for color scales is actually done from 380 to 720 nanometers. I believe since there is a UV light source, a UV component in the light source, I believe the answer would be yes. But I never like to, recommend something or give a 100% yes answer without being certain. So I think the best thing to do, if that's something you'd be interested in, would be to send me some samples, and I can go ahead and test those for you with the instrument. Okay.
Yeah. He did follow up, meaning optical brighteners. And Mark, let me unmute you if you'd like to kind of describe the situation, if you would. Are you there, Mark? Mark, are you there? I've unmuted you. You could be muted on your phone or your computer also. Okay, we can't hear you, but I see you typing. Did that answer your question? We'd be happy to do some testing, with the email you receive, or feel free to reach out to any of us. Okay, great, thank you. You're welcome. Another question from Dustin. Let's see where to go now. Are the alpha range scale matched up for specific frequencies that match up with the archaic methods? Or what are the APHA range integrations considered? Or does it integrate with the whole spectral range? Dustin, that's a mouthful there. Dustin, let me unmute you.
Okay, yeah.
Are you there, Dustin?
I am. Can you hear me?
Maybe you can say it better than I can.
Sure. So I have a couple of different instruments here where I'm not actually getting the same APHA results. And my curiosity is the old Nestlerizer tool where you've got the 300 millimeter path length, and you're comparing the two little deals with the glass wheels and so forth. It seems like in the base of those old instruments, there's a filter that's focusing in on strictly the yellow range. Do the digital instruments like the BIC, LCM, and LCS, do they integrate only that range, or are they looking at green and red and purple and orange and every single color under the sun, or are they strictly focused on kind of that same series of wavelengths?
So that's a tricky question because so the LCS and the LCM do measure using the full visible range of wavelengths. The LCM, or I believe APHA, the evaluation is always done under the C illuminant, which is a daylight illuminant, and the 2-degree observer function. So it does use the entire range for it, but APHA itself is more or less a yellowness scale. So it really is kind of isolating the yellowness of the sample, and that allows it to sort of make it into a linear scale that's just 0 to 1,000 rather than something like LAB, which is a 3-dimensional scale. So it keeps it a bit simpler. But yeah, it really does focus on the yellow, and if it's not a perfectly yellow sample, or if it's too much off yellow, it would really just be off scale, and the APHA wouldn't be the appropriate scale for that.
Right, okay. Thank you.
Okay, glad that helps, Dustin. Next question here from Mark. What kinds of measurements are or can be made for pearlescent, metallic, glitter types of fluids other than LAB color?
So our BIC MAC-I instrument, in addition to measuring LAB color at 6 different angles, which is important because when you have those types of special pigments in there, you can get what we call light dark flop or even color flop. which is where the lightness and darkness or even the color of the material changes from observing angle to observing angle just due to those special pigments. So it is necessary to measure such materials at different angles, but in addition to those color measurements at different angles, it can also measure what we call sparkle and graininess. So sparkle is just a measure of that sort of sparkle effect that you get if you're talking about, like I don't know, a nail polish with sort of a glitter pigment in it. It can evaluate both the size of that glitter effect of the individual particles that provide that glitter effect, as well as the intensity of the flash off of those that glitter effect. So if you want to know more about the capabilities of that instrument and ways in which it might be able to help you measure materials like that, I encourage you to reach out to me via phone or email, and we can discuss it further.
Mark, did that help? I've unmuted you.
Yes, thank you.
Okay, you're welcome. Great. And like these folks are asking, if you have any questions, comments, anything we can help with, please enter them in the Q&A box located in the bottom right-hand corner of your screen. Another question, Corey here. What cuvette is best used for Hazen measurement?
For Hazen measurement, you could use any of them, the 10 millimeter square, the 11 millimeter round, or the 50 millimeter. Just be aware that you're only going to want to compare measurements taken with the same cuvette. So you don't want to compare a measurement taken with a 50 millimeter cuvette with another liquid that was measured using a 10 millimeter cuvette, because it may show measured differences where visually there are none, or vice versa.
Okay, thank you. Another question here that one of our regional sales reps gets quite often, is it okay to use deionized water instead of distilled water?
No. So they're both very pure forms of water. It's actually somewhat common to think that you might be able to use deionized water in place of distilled water. But distilled water is more pure than deionized, and so when calibrating the instruments, they're calibrated with distilled water, and it really does need to be distilled water because the instrument is sensitive enough to pick up the difference. And I've seen firsthand where calibrating with deionized water can throw off the measurement results.
Okay, great. Are there specific questions you get a lot, Corey, relating to measuring liquids or transparent type solutions?
So I think one of the most common questions or issues that comes up with will this instrument work for me is how transparent does the material need to be in order to be measured with this with the LCS or the LCM, which are essentially transmission spectrophotometers for liquids, and so the light has to be able to pass through the material in order for the instrument to do the evaluation. And if the material is too opaque, if it's reflecting or absorbing too much of the light, not allowing enough of it to pass through, the instrument is incapable of doing a evaluation if there's not enough light to evaluate. So yeah, the question that comes up is how opaque is too opaque for this instrument? I wish I had sort of a definitive answer on when it can be used and when it can't. I don't, but again, that's a case when I would encourage you to send me some samples, and I can take some comparative measurements and see if the instrument will suit your needs.
Mm-hmm. And that's just another point there, Corey. One of the services and things that we offer at Gardner is sample testing like that, just to make sure one of our instruments, will work and what instrument is appropriate for you. So keep that in mind, and don't be afraid to reach out to your regional sales manager or to Corey directly. We'll get you his information in the follow-up email. Anyone from the field team or anyone else from the big team that's on the call, are there questions that you get frequently relating to transparent color measurement that we can review and go over for the sake of the participants on the phone?
Hey, John, this is Greg. Can you hear me?
Yes, sir. Hey, Greg.
Just an additional comment to that last answer from Corey. There are other cells available that go down to thinner path lengths. So a thinner path length cell combined with diluting the sample can give you a pretty large operating range for, I'll say, just about anything that you wanted to try to measure. It's just a matter of how much dilution you have to do and then correlating that to the end product.
Good point. Good point. Okay, another question here from Mark. Due to COVID, how is training conducted on new equipment purchases?
I'm sorry. Was the question specifically during the COVID pandemic? How is it conducted? Was that question?
Well, now with COVID and with travel limitations, how is training conducted if someone were to purchase a new piece of equipment?
We would conduct training remotely because yes, we can't travel right now. We can't go on site to train you, but we do training remotely via webcam, so we can actually set up a webcam and walk you through the instrument over the web. You can have your instrument set up with you, and I'll have an instrument, or whoever it is will have an instrument set up in their office, and we can go through it together.
Yeah. Great question, Mark. Yeah, we've been doing quite a lot of virtual demos of equipment, talking through different situations and coming up with solutions. So, yeah, it's unfortunate that COVID's here, but, we're all finding new ways of working, new ways of adapting to keep things moving. So and that's, one of the reasons why we've really started these office hours, was to continue online virtual education of not only a variety of solutions and situations around color, appearance, and physical test measurements, but also to interact more with people out in the field, our customers, to work through potential challenges, issues that they may be seeing in their facilities. So we've had great success. We've got a lot of great feedback from running these. We will continue these, but at a slower pace than what we did earlier this summer. So stay tuned for future invites. If you have a certain situation, feel free to reach out to any of us. Our regional sales team and inside sales team are broken up into territories, and they can help work with you directly and bring in Corey and other experts when needed. Other questions, please enter them in the Q&A box. Also, just a reminder, we are recording this. Corey's presentation, as well as a link to the recording and this discussion, will be sent out probably first thing in the morning to you. But if there's anything else we can help with here, we have a lot of experts on the phone here. Corey, as well as members from our business line team, management team, and regional sales team. So we'd love to help. The time is yours. If you need us to, we won't hold you if you got better things to do, but we want to be here as a resource and help where we can. So any questions or comments, please enter them in the Q&A box. And Jim, one of our, we cannot hear you, sir. It looks like you're unmuted on this end. Is it muted on your phone? Sorry, unable to hear you, Jim, still. So with that, we'll give it another minute or so, and if anyone has any last questions, please log them in the Q&A box. We'd love to help you out here. I think Jim, our business line manager for users, he's typing in. He's unmuted, but still can't hear. No, sorry, Jim. You can type it in if you have a comment. I'll read it. That'd be fine. Also, Mark, how do I find my account rep? That's done by territory. Mark, I'll reach out to you directly following this presentation and connect you with the appropriate account rep, inside salesperson, and their contact information. Okay. Corey, any final thoughts from you, sir?
Not a thought in my head.
You got it all out. Good. All right. Well, with that, I think we'll conclude. But thank you, everyone, for joining us. Good questions, good discussion here. Look forward to the follow-ups with the recording link, also the presentation materials that Corey shared, and also be on the lookout for invitations for future webinars. So with that, have a great rest of your day, and reach out to any of us if you need assistance at all. We'd love to help. Thank you.
Thanks, guys. Have a good one.